All right, everybody, good morning. It is Tuesday, March 24th, and obviously we had our last, office hours session on Friday where I went over a bunch of the Power series into Maclaurin series and Taylor series, and I think that was a pretty good video to get you guys kind of going in that direction. So since that time, we have gotten an update from AP Central, and I want to bring it up. Here's the update that they have given us, and I sent this out to you. I just looked at the important stuff for you for this class, although I know for some of your other classes this might be interesting as well. But anyway, if you just do a Google search for AP coronavirus update or something like that, I'm sure it would come up. Anyway, this is what it kind of says, and I went over this in my post in Google Classroom. But basically, the traditional face-to-face exam administrations will not take place, and students will take a 45-minute online free response exam at home. So that's kind of what we have going on right now. They do tell us that there will be 2 different testing dates. They've not given us those dates yet. It says some students want to take the exam sooner rather than later, while the content is still fresh, and others want more time to practice and review. So all this stuff will be available on April 3rd. That's not this Friday, but next Friday. So, just about 2 weeks away, we're going to find out, more information and exactly when those testing dates are going to be. But what was a 3-hour and 15-minute AP exam is now a 45-minute AP exam. Okay, so that's what they're doing. And instead of having all of you guys in the gym taking it all together, now it's going to be just you guys taking it at home. I put out there on Classroom, if you do not have access to, for a way to take this and you need extra support, whether that's a Chromebook or something like that, email me, and I will make sure that we get that for you. And then a little bit more information. Anyway, I'll post this site in Google Classroom after we go through this, but it has all of the different classes, and here we are for AP Calc BC. We have the 2 asterisks right here, which tells us down here that there's not going to be a subscore this year. So usually there's an AB subscore that goes along with it. There's not going to be that AB subscore. And then units 1 through 8, okay, we've already done all those. And 5 topics in unit 10. Unit 9 is the one on parametric, polar, and vectors. That's no longer going to be tested. This column is what's not tested. Exam questions will not cover anything on parametric, polar, or vectors. And then a lot of chapter 10 or unit 10 is not covered except for 10.2, 10.5, 10.7, 10.8, and 10.11. So when we talk about what those are, we have that here. Well, I'll get to that in just a little bit. But basically, here's what it comes down to. You know how I was going back and forth whether I just start at the beginning of, the series unit and then work through there. But I said, I want to get to the hard stuff first. I'm really, really glad that I did that, because a lot of the concepts that are omitted or not tested on this year are the ones that I skipped over. And, the Power series and Taylor series and Maclaurin series and all that stuff, even that is not really tested. However, what I've given you is really beneficial in order to understand what they have down here, which is 1011, which is finding Taylor polynomial approximations of functions. And that's what I'm really going to dive into today. And that's what I'm going to start with today. And having the knowledge of power series and what power series even are with Maclaurin and Taylor series, that's going to just make it so this is easier for us to understand. So, and then there are certain sections that we'll go over, like geometric series, but like I put, you've already dealt with that. You know whether a geometric series converges or not, just based on whether the common ratio is in between -1 and 1. But anyway, I'll go through all that stuff today as well. But that's what we got going on. Let's go ahead and talk about, yeah, this I put together just kind of talks about the different, you know, topics that are going to be covered, and specifically what is, what you need to know. So for within unit 10, they have 10.2 geometric series. And really what it says is a geometric series is a series with a constant ratio, or we call that a common ratio, between successive terms. And then if A is a real number and R is a real number such that R is in between -1 and 1, or the absolute value of R is less than 1, then the geometric series converges and is exactly equal to the first term divided by 1 minus a common ratio. So we've already kind of talked about that, but anyway, that's geometric series. Harmonic series and the P series, I will get into that. That's very easy. That's the easiest test. You know, I have my series test worksheet that's on my website. That's the easiest test that we talk about. Alternating series, well, these are series that alternate between positive and negative, and just talking about when they converge or diverge, which I'll get into. Ratio test, we've already talked about that in dealing with the power series for the radius of convergence and all that. Well, the radius and interval of convergence will not be on the test. However, the ratio test for convergence will be on the test. And so I'm going to talk about how to use that to determine convergence or divergence of a series. And then this Taylor polynomial approximations is what we have going on there. Remember, it talks about the coefficients, and I worked this out for you, how we got that the coefficients are just the nth derivative of f evaluated at, they use A, we used C, centered at C, they use centered at A, so whatever. So the nth derivative of f evaluated at whatever it's centered about divided by n factorial. That's what we got going on for the coefficients. These are the coefficients of the nth degree term. And then talking about the Taylor polynomials for a function. So we did that, talking about not just the, you know, linear approximation, but, you know, an approximation, any polynomial of degree 2 or 3 or 4, anything, right? We use these nth degree Taylor polynomials to approximate really, you know, complicated functions. But it's that same concept as, you know, linearization or linear approximations. So that's kind of where I'm going to start today, is because I've been working with these Taylor and Maclaurin series, and now I'm going to just dive in a little bit more on these Taylor approximations, or the nth degree Taylor polynomials is what they're oftentimes called. Okay, Michael, you have your hand up. What's up, dude? So Michael asks, since the AP test will be for response questions, how will that work for us, especially since we can't work directly on the problem? A lot of the teachers are wondering the same thing. You know, they've talked about back in In this, what they've kind of talked about is possibly even taking pictures. So where does it say students will be able to take these streamlined exams on any device they have access to, computer, tablet, or smartphone. Taking a photo of handwritten work will also be an option. So we don't know. We've never done this before. I don't have an answer as to exactly how this is going to work. But what they have said is on that April 3rd date, they are also going to give us, where is this? They have on here somewhere that they're going to tell us what types of problems are going to be on the free response. I think that's my interpretation of it, is they might say something to the effect of, this is going to be, there will be a free response question covering series, infinite series, or they might say covering, the accumulation of change, or, something like that, just to kind of guide us a little bit or direct us, but not really sure on how that's gonna work. Tyler Lentz also asked if the test is gonna be open note, or if that would be considered cheating. Again, how the heck are they going to know what you have if it is you taking it at home? I don't know. I'm looking for them to be more clear with us on what that's going to look like. But again, that's something I just don't know. Yeah. Okay. But I think it's time, guys. I think it's time for us to kind of dive in. But before we dive in, I think it's also time for us to get our carrots or crunching devices out. Are you guys ready for that? I'm ready. As I get this up. I think it's time. Let me get a good one. There's so many good ones to choose from, but I'm gonna go with, oh, that one looks good. This guy looks good. All right. So I'm gonna unmute all of you. I can unmute all of you. As soon as I do, I wanna hear like a what's up real quick. I'm gonna video this actually on my phone as well. Bam, so I know I'm recording this, but I still want this. All right, here we go. All right, I'm gonna unmute you all. I just want to hear a what's up. Ready? What's up, everybody?
What's up?
Oh my God.
Hello. Hey.
Whoa, everyone just freaked out. Okay, I'm gonna mute all of you. I'm gonna mute all of you. Okay, now I'm gonna do that again. This time I don't want any what's up or whatever, but all I want is a crunch. Okay, I'll count you down. I'm gonna unmute you on the count of 3. Ready? Well, I'll unmute you and then I'll count down from 3 to crunch. All right, everybody's unmuted. No laughing. Okay, ready? On the count of 3. 1, 2, 3.
Oh my.
Ew.
That was pretty good.
ASMR.
Crunch the bag.
He's gone.
It definitely wasn't as good as this guy. Hold on, wait, where is it?
Oh man.
This guy right here. Yeah, that was the real deal. Oh, I gotta mute all of you again. Hold on. All right. All right. Can you guys all see Tuesday, March 24th again? All right, cool. All right. Apples are good. Apples, they crunch. That's all good, Keaton. Okay, so we're gonna dive in, okay? And I'm not really gonna go through all of the, review of the previous lessons because you have them, they're on my website, which is, I just have a link to my YouTube channel and all that. So they're there. I am going to do just a very, very brief reminder for what Taylor series are. So let's go ahead and Taylor series. So what we have here is a function is equal to the summation as n goes from 0 to infinity. So Taylor series are these infinite like polynomials. And what we have is we started with, and then I'm going to change this, a sub n times x minus c raised to the n power, right? But then this is just a power series, but a sub n is equal to the nth derivative of f evaluated at c over n factorial. So what we did is we replaced a sub n with that. And this is the Taylor series, for the function f centered at c. But again, this is an infinite series. Now what we're doing is we're saying, okay, let's kind of use what we know about these Taylor series, but instead of having this infinite number of terms, let's have it so it's a finite number of terms, and let's go up to degree whatever. It could be going up to degree 5 or degree 3 or whatever it is. So that's going to give us a polynomial of degree 5 or a polynomial of degree 3 that will best approximate like a really complicated function, similar to how, we dealt with linear approximations, approximating these difficult functions, but just using a line. So let's dive into an example, okay? So here we go. Here's an example. Let's say I gave you, find the third degree Taylor polynomial. Shoot. To approximate f of x equals, let's make it, let's start with sine of 3x. About x equals 0. So we'll start at x equals 0 for our first example, and then we'll do more and more complicated examples after this. So here we go. Find the third degree Taylor polynomial. Well, here's what we do. We know that f of x is going to be approximately equal to, let's call it t sub 3 of x. So this is what I'm calling, this is the third degree Taylor polynomial. Okay, this t sub 3 of x, the capital T stands for Taylor, and sub 3, the 3 is the third degree Taylor polynomial for x, and we know that it's going to be centered at x equals 0. If you remember from the last video I did talking about the Maclaurin series, you know that a Taylor series centered at 0 really is a Maclaurin series, but we don't call them Maclaurin polynomials or something like that. We always call them Taylor polynomials, even if they're centered at 0. Okay, so here's what we know this is going to be equal to? This is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 times x squared plus f triple prime of 0 over 3 factorial x cubed. Where is this coming from? Well, it's coming from this. But so I'm plugging in when n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, and then I stop because I have then reached the third degree, right? N is equal to 3, that's the third degree. So when n is equal to 0, it's the 0th derivative of f, which is just f, evaluated at c. In this case, c is equal to 0. So that's f of 0 over 0 factorial, which is just 1, times that thing to the 0th power, which is just 1. So that's how I get this term right there, f of 0. Next, when n is equal to 1, well, the summation says plus, right? When n is equal to 1, I have the first derivative of f evaluated at 0 over 1 factorial, which is just 1, times x minus c, but c is 0, so it's just times x to the first power. That's how I get f prime of 0 times x. Then, when n is equal to 2, the second derivative of f at 0 over 2 factorial times x minus 0 squared, so times x squared. And then the last one is when n is equal to 3, the third derivative of f evaluated at 0 over 3 factorial times x minus 0 cubed, right? So that's where this comes from. Does everybody see that? Does that make sense? Where the third degree Taylor polynomial for this function comes from? I'm gonna take that as a yes. Is anybody there? Okay, so we have to find f of 0, then we have to find f prime of 0, then we have to find f double prime of 0, then we have to find f triple prime of 0, right? Those are the things that we need in order to come up with this third degree Taylor polynomial. So let's do it. So this will be, I guess, my little side work over here. What is f of 0, f prime of 0, f double prime of 0, and f triple prime of 0. These are the things that I need to figure out. So now I go back up and I say, okay, f of 0. Well, f of x is sine of 3x. What is that evaluated at 0? What is sine of 0? Oh, this is not going to be a fun one. Yeah, so that's going to be 0, right? So then f prime of 0. So f prime of 0, what is f prime of x? First of all, if f of x is sine of 3x, what's f prime of x? So I should leave little spaces in here. Okay, so I'll do it over here. F prime of x, if f of x is sine of 3x, f prime of x is 3 cosine of 3x, right? So what's f prime of 0? Three, right? And so if I have f double prime of x is equal to, so that's going to be -9 sine of 3x. What's f double prime of 0? Zero, right? And then f triple prime of x is equal to negative 27 cosine of 3x. So what's f triple prime of 0? Negative 27, right? Good. So now I'm going to replace each of those, numerators of the coefficients or the derivatives of f evaluated at 0 with what we found them to be. Because right down here, right, so we can see both, I have that this goes for the yellow, this goes for the green, this goes for the blue, and this goes for that pinky purpley, right? So I'm just going to replace f of 0 is just 0. So up here, I'm going to say, hold up, wait a minute. That's going to be 0 plus that, meaning I don't even need that, right? Well, I guess I'll put it in for now, and then I'll make it better. 0 plus. And then that f prime of 0, we just saw, oh, that's just 3. F double prime of 0, well, that was 0. F triple prime of 0, right? That's negative 27. So t sub 3 of x is really equal to 0, I didn't need to put that, 3x, the squared term is just 0, and then, so negative 27 divided by 6, right? Because 3 factorial is 6. Well, that's going to give me what? 9 halves, negative 9 halves, so minus 9 halves x cubed. This is my third degree Taylor polynomial that approximates sine of 3x. I'm going to show you what that looks like in just a little bit, right? Because if you're wondering, that's 6. So I say, 3 goes into this. I'm left with negative 9, and 3 goes into this, and I'm left with the 2, and that's where the negative 9 halves comes from, right? Okay, so this is my polynomial of degree 3 that best approximates that function, which was sine of 3x. So let's go ahead and show you what that looks like. Okay, y equals. So let's clear this guy, clear this guy. All right, I started with sine of 3x. Let me just make sure that I'm in radian. Good. So down here, I'm going to plug in what? So that was 3x minus 9 halves x cubed, okay? So here's what we get when we graph that. Okay, I didn't center it, so let's go back to, so zoom 6. So this right there is your, original function, which is sine of 3x. And then you have this approximating polynomial, but this was only, remember, centered at x equals 0. So let's actually zoom in a little bit, or let's do zoom. Let's first do zoom trig, which is 7. And now let's zoom in from there. Okay, so I'm gonna zoom in right there. So what we did is we found a polynomial of degree 3, which is this red curve right here, right? And that best approximates this complicated trigonometric function about x equals 0, if we center it at x equals 0. So then the question might be, okay, that's cool that you're centering it at x equals 0, but what if it wasn't centered at x equals 0, right? So let me go back to zoom 7. So someone might say, what if you centered it at x equals pi, or x equals, negative 3 pi halves, or something like that? Well, wherever it's centered at, so let me go ahead and take a picture of this, and then I'll just show you a quick okay, so this is graphically what we just did, what we just found. The red is my t sub 3 of x. So that is t sub 3 of x, whereas the blue was my, f of x. You can see that it was centered at x equals 0. So f of 0 and t sub 3 of 0 are going to be exactly the same, okay? Because that's where it's centered. And then from there, before we had like a line, and we're like, oh, look at this line. It's a pretty good approximation, whatever, something like that, right? Oh, look at that. That's a good approximation for the blue. But it's not, it's only a good approximation for a line, right? I don't want that. I want something that's going to be much better of an approximation that curves along, right? We know about concavity, so that has a similar, concavity to the function as you go away from where it's centered, right? And so this is the polynomial of degree 3 that best shapes or forms to that shape of the graph, right? But like I was saying, what if we wanted to say, well, what if this guy was centered at, I don't know, like right there, this x value? Well, it's going to be this curve that goes like this, and it might dip down, and it, depending on what degree term you're looking for, it might look something like that, where from where it's centered about, it's really closely fitting to it, and then all of a sudden, over here, I get it, the air is more and more, right? So over there, not good, for that approximation. And then over here, maybe it's up until this point, and then over there, it's not good. But from where it's centered at, going both to the right and left of where it's centered, so values slightly less than or slightly greater than where it's centered about, it's going to fit the curve or the graph of the function way better, okay? And it's going to be a much better approximation than just, say, a line. So that's what we got going on. Before I give you guys an example to work on, do you have any questions for me up until this point on Taylor polynomials used as approximations? You can raise a hand, use the chat, or just unmute yourself if you have a question. No, you're good? All right. So let's go ahead and let me give you an example to make sure that you understand this. Let's say, what if I wanted a 4th degree so that should be capital, Taylor polynomial of let's say f of x equals root x, and let's say this is centered at x equals 1. Now let's make it 4. Let's make it 4. All right, go ahead and work on that. I'm going to give you a couple minutes. I'm going to pause this recording right now. You have 3 minutes to get this guy. I'll give you 5 minutes. 5 minutes. And ask questions if you have them. I'm going to pause the recording. All right. So the first thing that we do is we check out and we say, okay, no matter what the original function was that they gave us, this happened to be the square root of x. But no matter what that was, if we have a fourth degree Taylor polynomial, that means I'm going to start when this is 4. Centered at 4, that means that these values inside are 4. This is what it's going to look like in black right here, right? That the function is approximately equal to the fourth degree Taylor polynomial of x, which is f of 4 plus f prime of 4 over 1 factorial times x minus 4 to the first, plus the second derivative of f evaluated at 4 over 2 factorial times quantity x minus 4 to the second, plus, right, all that stuff. So then what I did, and I did this in blue, I just said, hey, this is my original function, the first derivative, the second, third, and fourth derivative. And then I stopped at the fourth derivative because they only asked for the fourth degree Taylor polynomial, so that needs to go to 4. So now I'm doing f of 4, f prime of 4, f double prime of 4, all the way through. So let's go ahead and do that. So f of 4, the square root of 4 is 2, not plus or minus 2. And f prime of 4 is going to be 1 over 2 root x, which is 1 over 2 times 2, so that's 1/4. And next, f double prime of 4 is going to be negative 1 over, so it's going to be 4 times 4, so 16 times 2 is 32. Is that what you guys got for f double prime of 4? Negative 1 over 32. Okay, and then f triple prime of 4, or the third derivative of f evaluated at 4, is going to be 3 over, let's see, I have 8 times 4 times 4 times 2, whatever that is. So this is 3 over 16 times 16. What is that? Like 256 or something? Someone work that out for me. Yeah, okay, and then we have the fourth derivative of f evaluated at 4, and this is going to be negative 15 over 16 times 4 times 4 times 4 times 2. So what is that, like negative 15 over 2048? Something like that? Okay. So here's the thing I want to stress to you. These are the numerators of the coefficients. So these aren't just the coefficients themselves, these are the numerators of the coefficients. So going back up to, so I'm going to move this down a little bit. I'm going to move all this stuff down. Whoa! I didn't even know I could do that. That was cool. All right, so now I have that this is equal to f of 4, which is 2, plus f prime of 4 is 1/4 times x minus 4, plus, next I have f double prime of 4 over 2. Well, f double prime of 4 is negative 1 over 32, divided by 2 is negative 1 over 64, times x minus 4 squared, plus, here I have the third derivative of f evaluated at 4, which is 3 over 256, divided by 3 factorial. So that's divided by 6. Well, whatever that is, I think that's going to be just 1 over 512. Is that right? 1 over 512 times x minus 4 cubed. See if I did that right. 3 over 256 divided by 6. Someone do that for me. Is that okay? Cool. And then plus the fourth derivative of f evaluated at 4 over 4 factorial. So that's this over 4 factorial. I'm just going to write that out for now. Negative 15 over 2048 divided by 4 factorial times x minus 4 to the 4th. Now, I know that 4 factorial is just going to be 24. So let me do that really quickly. Or you guys, someone do that for me. What's negative 15 over, so this is going to be 24. So let's see, a 3, that, and I'm left with 8, and 3 is 5. So what is that going to be? So this whole numerator ends up being negative 5 over 16,384. So this whole thing is, I think, negative 5 over 16,384 is the coefficient. Did you guys get that? The negative 5 over 16,384. No one's answering. Hello. Okay. Thank you, Maggie. Tyler got something different. What'd you get, Tyler? Yeah, so if you're doing it in your calculator, you're going to get some either decimal or scientific notation or something like that. But anyway, this is what we got. So now, t sub 4 of x is 2 plus 1/4 times x minus 4 minus 1/64 times x minus 4 squared plus 1 over 512 times x minus 4 cubed minus, I'm now going to erase this thing. So here we go. Minus 5 over 16,384 times x minus 4 to the 4th. Bam. Now, let's go ahead. I'm going to plug this into my calculator and make sure that this is a good approximation. So let's go ahead. Y equals, clear this guy. I'm going to say root x. Clear that guy. And now I'm going to start typing in what I got, which was, oh, I can't do that. Hold on. All right. Here we go. So this was 2 plus 1/4 times quantity x minus 4. Which, by the way, everybody, listen, stop doing what you're doing. Listen. Hey, this is what we would have gotten with just linearization or linear approximations, right? The first degree Taylor polynomial is exactly the same thing that we did for linear approximations. Didn't we talk about that where the linear approximation was f of a plus f prime of a times quantity x minus a? Well, if we stopped at degree 1, that's what we would have. Mind blown. Okay, cool. But we're not stopping at degree 1 for this. We're going all the way through degree 4. So let's do it. So minus 1 over 64 times x minus 4 squared plus 1 over 512 times x minus 4 to the third power, and then minus 5 over 16, 384 times x minus 4 to the fourth power. All right, so now I'm gonna hit, for my window, because this is centered at 4, let's go from 0 to 8 with a scale of 1. And let's have my y min value, I don't really know. I'm gonna go from negative 10 to 10 at first to see if that's good. And let's go ahead and graph this. Pretty good. Let's do my window from we'll do from negative 2 to 10. Well, you can see that my blue, which let's go back, the blue was my original function. That stops at x equals 0, right? Of course it does, because it's a square root function. And so the blue is my actual function, but what I'm saying is this red of degree 4 is the best polynomial of degree 4, or quartic, function to approximate this. So let's keep zooming out and see what we got going on with, check that out. This is what that function actually looks like, the red function looks like. But right around x equals 4, it really does a solid job. If I were to keep, going on and I do my window so that the x values go to, let's say, 20, I'll have them go by 2 there. Then we'll see there's going to be a drop off, right? So 2, 4, because my x value scale is 2, this is really where it hits, right? And so that function looks really, really, really good. The red one looks really good as an approximating function up until a point, and then it's got to drop off because I've limited it to just degree 4. But we can see if I did degree 5, right, this guy would be better and then would go up this way. Degree 6 might follow along that blue a little bit further. And 8 would be further and 10 would be further dropping down. All the odd ones would go up, right? Like, for example, let me show you. If I got rid of my last term that's of degree 4 and I stopped at degree 3, so all this stuff I want to delete. Shoot. And I graphed this guy. So again, well, let's go to, this is where it's centered again because my tick marks are 2. Let's change that. Let's make it so my x scale is 1 so you can see. Right, so 1, 2, 3, 4. So this is where it hits. But now, because I have a polynomial of degree 3 or a cubic, it's going to follow closely, and then it's going to go up this way. All right, and that's what it's going to look like. Talk to me. Does that kind of make sense for you guys? Do you think this this is doable, or do you have concerns, or do you have anything that you want to ask up until this point? It's really using. I like it. Students usually like it because it's using the same. Where is it? Formula right here, right? So this is the full Taylor series. But now if we limit it and say not, you know, as n goes from 0 to infinity, but as n goes from 0 to 3, or as n goes from 0 to 5, or whatever it is for the nth degree Taylor polynomial, you're still just, of course, you have to find all of those derivatives. So if they asked you to go to n equals 5, which, by the way, on the AP exam, a lot of times they'll say the second degree or third degree or maybe fourth degree, but usually not beyond degree 4. So what we just did, I did an example of the third degree and another one of the fourth degree. I would never anticipate them doing anything beyond fourth degree Taylor polynomial, but that's what we got going on, okay? It is very nice and methodical. I agree. I think it's, you know, you get some practice on it. And I do think, even though power series and everything about Maclaurin and Taylor series, you don't necessarily need to know all of that. I could have just taught this, you know, without teaching all that other stuff. But I taught you that other stuff before I knew that that wasn't going to be on the AP exam. But now I feel like that only makes it so so this makes more sense. Okay. So anyway, that's what we got going on for that, which honestly, out of everything that we have to learn that is on the AP exam that has not been taught yet, this is probably the most complicated, and I still don't even think it's that complicated. So I think it's doable. Okay. Okay. Do you have any other questions before I'm going to pause this or I'm going to stop this recording, and then I think I'm going to start another one. Where are we? We're at 11:30. Actually, I think that's good for today. Okay. On Thursday, what I'm going to do is I'm going to hit all the other guys. So the geometric series, where was that? Yeah, I'm going to hit the geometric series stuff. I'm going to hit the harmonic and P series, which is easy. I'm going to do the alternating series test and the ratio test, which I've already taught the ratio test, but we'll go over a bunch. I taught the ratio test with variables X. This is just, you don't even have the X's in there, so that's even easier. But anyway, you've already seen what that looks like. So I'll do all that starting on Thursday at 10:30. Again, if you ever have questions, you know, I want you to ask those, and I want to make sure that, you know, you know that I'm here to answer those. Okay. So here's what we have. This is not from Rogowski. Of course, I'm looking through Rogowski, and do you think he has good problems on this, what we're looking for? No, he doesn't. So I found this from Stewart's book, and I took a picture. I will upload this picture to my website. This is what I want you to do right here for your homework assignment. And I know there's a questions of, well, what about Khan Academy? Whatever that. I want you to pause everything that you've done in terms of Khan Academy, the progress that you've gone through, you know, where you're at right now. I want you to pause on that. And I want you to forget about the homework assignments from my calendar. I'm going to tailor this to meet the needs of, you know, what we need for the AP exam. And this is something that I think is going to be the best to get you ready for this, and so you can practice. Basically what this is the n is the nth degree Taylor polynomial, so to degree n, and the a is what it's centered at. And so you're going to be doing these problems, just 3 through 10, before we meet again on Thursday. Let me see really quickly. I know that for let's just have you do that. That's what I'm gonna have you do. You can also look up, Taylor approximations and, get more problems. I know, on Khan Academy there, if you just put in Khan Academy Taylor approximations, I know there's a bunch of good stuff. Let me show you. Oh, this is his intro part 2. But anyway, so this.
In the last several videos, we learned how we can approximate an arbitrary function, a function that is differentiable twice differentiable. How we can approximate a function that is
So anyway, he goes through. Anyway, there are a lot of resources out there, and that's my main point. Is there are a bunch of resources out there for you, but that's what I want you to focus on are these problems right here. I will start Thursday's session by answering some of these questions if you have questions on them, and then I'm going to dive into the rest of it. Okay. All right. Anything else that you guys, any other questions just in general for the class, for this specific concept, or anything else that you guys want to ask as of right now? Okay, so these problems are not from Rogowski. They're from Stewart. Rogowski has, for Taylor series, his is section 10.7. And problems 29 through 38. For Rogowski, if you wanted extra help, you could do problems 29 through 38 from section 10.7. However, he doesn't give you go up to degree 4 or whatever. He just says find the whole Taylor series, which we don't need to do. We don't need the whole infinite Taylor series. That's the summation notation. But you could do that. But what I'm giving you right here, this picture, which I'll put on my website, is from Stewart. Stewart has a section 11.12 that goes over that, but you don't have Stewart's book. But if you could find it, that'd be good. Yeah, Lizzie, that's what we've kind of said is 11:15 is when they kind of go to Mr. Minyard's session. I know you just sent that to me privately, and then that's why I record this and I put it up there so you can take off. I will put, me just asked where on the College Board site does it show what topics are going to be on the exam. I will put that link on my website as well. So on my website, I put the link to the AP, the updates for the coronavirus updates for the AP exam. I'll put that link, and I'll also put this image that has all the homework problems that I want you guys to do. All right. Yeah, I'll upload the answers as well, Tyler. That's a good point. And me, I think I responded to that, to your email. But really, if you just like pause on, yeah, if you pause on the Khan Academy stuff, honestly, you know, I was having you do that to get certain things that I was then going to teach to make it easier for me to teach those. But now, because we have limited, they limited the number of sections that are going to be on the test, I'm just going to have you pause on that. All right. Yeah, so as of right now, we're disregarding the calendar assignments. I will get, like, it's been a scramble for all of us, you know, for me to go through everything, but I will get you something. I know you guys like that calendar that has things, you know, to get you set up for like a couple weeks at a time. I will have that. Hopefully by Thursday, I'll have that for you. But there's just been new information rolling in. So I'm kind of like, you know, I want to give you as much as I can give you without having to then say, okay, now scrap that and do this. Okay, now scrap that and do this. So that we could go from there. So really what you need to do is this assignment that I'm giving you right here by Thursday. And that's about it. Any other questions for me? Also, yeah, send me either an email or something about where you know, colleges that you've heard back from that you've gotten into. And I know some are waiting for the end of this week. But that's what we got going on. Sean, did I get your email regarding your grade? Yeah, I'll email you back. As for the homework right now for submitting it, let's, you can ask me, I mean, you could email me just like, hey, Mr. Groller, I got caught on this, and you could take a picture of your work and email that to me. Let's do that individually. Or I think you can post it in Google Classroom. You could send me a message that way, but do it that way individually if you do have questions. But like I said, I'm going to post this. I'll post the answers to these questions, and I'll post that site to my website, right? The site to the College Board, the AP Central. I'll post that to my website. All right. All right, everybody. Good job. I'll do all that stuff and get it posted within the next half hour. Cool. I'll see you guys on Thursday. Have a good rest of your day and stay healthy.